Hi everybody. Yesterday we had seen some basic concept about trigonometry and about triangle, side, angle. Just a small recap about that. So this, hope you know, this is called triangle. You will have vertex points, you have sides, and you will have angles. So we have in this subject, in about your curriculum, we are going to deal with right angle triangles. Hope you know about right angle triangle. There will be a 90-degree. The side opposite to right angle will be called as hypotenuse, as I said yesterday, and the side opposite to theta will be called as opposite side, and the side adjacent will be called as adjacent side. These all things yesterday we had seen, and today we are going to see about trigonometric identities. See, trigonometric identities is most important thing, and with this trigonometric identities only, we are just going to solve some proof problem. You will have most probably you have some around 20 to 30 problems, around 20 problems. All the problems are proof problems. So we'll have some cos theta, we have sin theta and other things. So yesterday we have seen about some basic measurements of theta values, that is sin theta, another one is cos theta, and you have tan theta. See, sin theta is nothing but it is the reverse of 1 by cosecant theta. Cos theta is inverse of 1 by secant theta. Tan theta is inverse of 1 by cot theta. See children, I'll give you an idea. See sin theta will be inverse of cosecant theta. See the cosecant theta. What is the third letter here? In cosecant theta, you can see third letter is S. So S is the sin theta, S represents the sin theta. So whenever you see cosecant theta or sin theta, 1 by of cosecant will be sin theta, or 1 by sin theta will be a cosecant theta. Similarly, see the secant theta, the third letter is C. See, cos theta. So when cos theta comes, you can mention it as 1 by secant theta. When secant theta comes, you can mention as 1 by cos theta. Likewise, see, T is the here. What letter here? It is the third letter is T. So tan theta is the inverse of cot theta, and cot theta is inverse of tan theta. You should remember these things. When you get this, remembering these things, you can easily solve trigonometry. Sin theta equal to 1 by cosecant theta, cos theta equal to 1 by secant theta, tan theta equal to 1 by cot theta. And I will give you another idea of most important and interesting ideas. Tan theta equal to nothing but sin theta by cos theta. So all these theta will include here. Tan theta equal to sin theta by cos theta. Already you know sin theta, you know cos theta, and you know tan theta. Tan theta is nothing but sin theta by cos theta. These are the most important identities and their basic structures in trigonometry. Let me go about three important identities. The first identity here is sin square theta plus cos square theta equal to 1. This is the most important identity. We will be using this identity in many problems. So whenever you see sin square theta plus cos square theta equal to 1, or whenever you see sin square theta plus cos square theta, you just want to get into an idea. This we are going to use identity 1 here. See, sin square theta can be also written as 1 minus cos square theta. When this cos square theta comes beyond the equal to sign, it will become minus. So we can write here sin square theta equal to 1 minus cos square theta. Similarly, cos square theta can be also written as 1 minus sin square theta. So this is the first identity. This is the subsidiaries or the kids of this identity. With this idea, with this identities, you can solve as many as number of problems in your textbooks, right? Now we are going to see about second identity. Identity number 2 is 1 plus tan square theta equal to secant square theta. See, as like the first identity, sin square theta plus cos square theta equal to 1. Here is the second identity. It's 1 plus tan square theta equal to secant square theta. Whenever seeing the problem, if tan square theta and secant square theta comes in that problem, you should have an idea. You should have a creative idea. You can use this. You're going to use the identity number 2. See, similarly you can write tan square theta equal to secant square theta minus 1. This plus 1 goes beyond the equal to sign, it becomes minus 1. Similarly, secant, you already wrote here, secant square theta minus tan square theta equal to 1. See, secant square theta, when I'm bringing this tan square theta beyond the equal to sign, it will become minus tan square theta. So these are as like first two identities we got some subsidiary identities or kid identities. These are the subsidiary or kid identities of number 2 identity. 1 plus tan square theta equal to secant square theta. From this we derived these two identities. And we are going to see about the third identity. The third identity is nothing but 1 plus cot square theta equal to cosecant square theta. As like the first two identities, we can write similarly here. Cot square theta can be written as what? That's cosecant square theta minus 1. This 1 will go that side. Similarly, we can write cosecant square theta minus cot square theta equal to 1. So these are the, again we are getting some subsidiary identities from the main identity. Totally we have 9 identities. First identity is sin square theta plus cos square theta equal to 1. Second identity is 1 plus tan square theta equal to secant square theta. Third identity is this thing, 1 plus cot square theta equal to cosecant square theta. So totally we will have 9 identities. We can easily solve from this identities. Let us get into the problems from tomorrow onwards. Thank you, kids.